At 0500 hours on March 7th, 1945, elements of the 9th Armored Division's Combat Command B reached the western edge of Remagen, Germany. The Rhine River lay directly ahead. Between the American spearhead and Germany's last natural defensive barrier stood the Ludendorff Bridge, a massive railroad span stretching 512 feet across the swift-flowing water. Staff Sergeant Alex Drabik of Company A, 27th Armored Infantry Battalion, would become the first Allied soldier to cross the Rhine when he sprinted across that bridge under intense German fire later that morning. But crossing the bridge was only the beginning. Holding it, and, more critically, keeping it functional under relentless German counterattack would require an engineering feat that seemed impossible. Lieutenant Colonel Harvey Fraser commanded the 51st Engineer Combat Battalion. His unit had been following the armored spearhead through Germany for weeks, repairing roads, clearing mines, and building temporary bridges over smaller rivers and streams. Nothing in their experience prepared them for what they were about to attempt. The Ludendorff Bridge was damaged. German engineers had attempted to destroy it as American forces approached. Demolition charges detonated prematurely, causing significant structural damage, but failing to drop the span into the river. The bridge was standing. Barely. It was usable temporarily. But every combat engineer who examined the structure understood it could collapse at any moment. American forces needed that bridge desperately. The Rhine River represented Germany's final major defensive line. Every other Rhine crossing was heavily fortified. German forces expected Allied armies to attempt crossings further north, near the Ruhr industrial region, or further south, near Karlsruhe. Remagen was unexpected. The bridge's survival, however temporary, represented an extraordinary strategic opportunity. If American forces could exploit this crossing quickly, they could establish a bridgehead on the Rhine's eastern bank before German forces could organize effective counterattacks or destroy other nearby crossings. But the damaged Ludendorff Bridge could not sustain the weight and volume of traffic required for a major military operation. The structure was built in 1916 during World War I, designed to move trains, not endless columns of tanks, trucks, artillery pieces, and infantry. Even undamaged, it had limitations. Damaged, with twisted steel members and cracked concrete, it was a death trap. Combat engineers immediately understood what was required. They needed a second bridge. They needed it immediately. And they needed to build it while German artillery, mortars, aircraft, and commando raids attempted to destroy both the existing bridge and prevent construction of any replacement. The mission fell to Company A, 291st Engineer Combat Battalion, reinforced by elements from the 51st Engineer Combat Battalion and the 299th Engineer Combat Battalion. These units, combined, represented approximately 300 men. They had bridging equipment, construction materials, hand tools, welding gear, timber, steel components, and pneumatic tools. They had bulldozers for earth moving. They had cranes for lifting heavy structural members. They had everything except time and safety. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lieutenant Hugh Mott commanded the bridging platoon from Company A, 291st Engineers. He was 23 years old. He had graduated from Virginia Military Institute in 1942 with a degree in civil engineering. He understood bridge construction theory from classroom instruction. He had practiced building pontoon bridges during training exercises at Fort Belvoir, Virginia, and later at bases in England before the Normandy invasion. He had repaired damaged bridges under fire in France and Belgium, but he had never attempted anything approaching this scale under these conditions. The plan was technically straightforward. Engineers would construct a heavy pontoon treadway bridge parallel to the damaged Ludendorff Railroad Bridge. The new bridge would use M2 steel treadway sections supported by pneumatic floats. Each treadway section measured 15 feet long and weighed approximately 600 pounds. The floats when inflated with compressed air, provided buoyancy to support vehicles crossing the span. Standard American engineer doctrine called for construction times of 12 to 18 hours for bridges of this length under ideal conditions. Ideal conditions meant no enemy fire, adequate working space, proper lighting, calm water, and experienced crews working from detailed plans. Remagen offered none of these advantages. German artillery observers on the heights east of the Rhine had clear fields of observation covering both the damaged railroad bridge and the proposed construction site. Artillery shells began falling minutes after American forces secured the western approach. German batteries fired from positions in the Westerwald Hills, approximately 6 miles east of the river. The guns included 88mm pieces, 105mm howitzers, and heavier 150mm guns. Forward observers adjusted fire based on observed impacts. Shells walked up and down the riverbank. Explosions threw geysers of water, mud, and shrapnel across the construction area. The Rhine current at Remagen flowed at approximately 4 miles per hour in early March. This velocity created significant engineering challenges. Pontoon bridges require anchoring to resist current forces. Each pontoon section must be positioned precisely and secured before the next section connects. Working in flowing water is dramatically more difficult than working in still water or on dry ground. Engineers working from small boats attempting to maneuver heavy steel sections while the current pushed constantly downstream required exceptional skill and physical strength. German aircraft added another dimension of danger. The Luftwaffe, though severely weakened by years of attrition, mounted desperate attacks against the Remagen bridges. Messerschmitt fighter bombers dove through American anti-aircraft fire to drop bombs and strafe engineering positions. Junkers 88 medium bombers attacked at night. The attacks came in waves. American anti-aircraft units shot down many aircraft, but some bombs found their targets. Near misses created waterspouts that swamped pontoon sections. Direct hits destroyed equipment and killed engineers. German commando teams infiltrated across the Rhine at night. Frogmen equipped with explosives attempted to attach demolition charges to pontoon sections and bridge supports. Some succeeded. Explosions rippled through sections of the developing bridge. Engineers worked constantly to repair damage, replace destroyed sections, and maintain construction progress despite these attacks. The construction began at 1400 hours on March 8th. Lieutenant Mott positioned his men along the western riverbank, approximately 100 yards south of the damaged railroad bridge. The first task involved preparing the launch site. Bulldozers graded the shoreline to create a gentle slope, allowing pontoon sections to be rolled into the water. Engineers cleared debris, removed obstacles, and established working positions. The bridging equipment had been brought forward on trucks. Each M2 treadway section required 6 men to maneuver safely. The sections were unwieldy. The steel was heavy. The dimensions were awkward for manual handling. Engineers worked in teams. They unloaded sections from trucks, carried them to the water's edge, and prepared them for assembly. The pneumatic floats required inflation before use. Engineers connected compressed air lines and inflated each float to proper pressure. This process took time. Each float had to be checked for leaks. Underinflated floats would sink. Overinflated floats risked rupturing under load. The assembly process followed established procedures adapted to combat conditions. Engineers positioned the first treadway section at the water's edge. They attached pneumatic floats to mounting brackets underneath the steel deck. When floats were secured and properly inflated, they pushed the section into the water. The current immediately grabbed it. Engineers in small boats maneuvered the section into position using ropes and muscle power. They fought the current constantly. The boats were 12-foot plywood assault craft powered by small outboard motors. The motors were barely adequate for the task. Engineers rowed when motors failed or proved insufficient. Once the first section floated in approximately correct position, engineers connected it to anchor cables. The cables ran to dead men buried deep in the riverbank. The dead men were heavy timbers or steel anchors providing resistance against current forces trying to sweep the pontoon downstream. Proper anchoring was absolutely critical. Insufficiently anchored pontoons would break free and drift away, potentially destroying work already completed downstream. With the first section anchored, engineers began connecting the second section. Connection required precise alignment. Steel pins passed through matching holes in adjacent sections, creating mechanical connections capable of transferring loads across the joint. The pins had to be driven fully home and secured with locking devices. This work was difficult on dry land. In flowing water, from small boats, under artillery fire, it became extraordinarily demanding. German artillery fire intensified as construction progressed. Forward observers recognized what was happening. Destroying the new bridge became a priority German objective. Shells impacted continuously. Some fell short, exploding in the river and creating massive waterspouts. The concussion from underwater explosions was severe. Engineers working in boats near impact points were thrown into the water. Some drowned, some suffered blast injuries, others climbed back into boats and continued working. Shells that landed long impacted on the western riverbank, among equipment, supply dumps and staging areas. Trucks were destroyed. Bridging sections were damaged. Men were killed and wounded. Medics worked continuously, treating shrapnel wounds, broken bones, and blast trauma. Casualties were evacuated to aid stations established in buildings several hundred yards back from the riverfront. The wounded were replaced immediately. Fresh engineers moved forward to continue the work. Night brought different challenges. Darkness prevented German artillery observers from seeing their targets clearly, reducing the accuracy of incoming fire. But darkness also made construction work dramatically more difficult. Engineers needed light to see what they were doing. Connecting steel sections required seeing alignment holes. Driving pins required seeing where hammers struck. Operating boats safely required seeing obstacles and other craft. Engineers used shielded lights sparingly. Bright illumination would draw artillery fire. They worked mostly by feel, by memory, by practiced familiarity with equipment and procedures. Progress slowed, but never stopped. Section by section, the bridge extended from the western shore toward the eastern bank. Each section added approximately 15 feet to the span. After 20 sections, the bridge reached 300 feet into the river. After 30 sections, 450 feet, the eastern shore was visible ahead. Close now. German frogmen attacked during the night of March 8th and 9th. They swam downstream, carrying waterproof explosive charges. American guards spotted some swimmers and opened fire with rifles and machine guns. Some frogmen were killed. Others turned back. A few reached the bridge and attached charges to pontoon floats. The explosions came without warning. Sudden flashes, sharp cracks, geysers of water. Pontoon sections ruptured and sank. Steel treadway sections tilted crazily as their flotation disappeared beneath them. Engineers responded immediately. They disconnected damaged sections before they could drag adjacent sections down with them. They brought replacement pontoons forward and installed them. They reconnected the bridge and continued building. The work never stopped. Crews rotated every few hours. Exhausted men came off the bridge. Fresh crews went on. Food came forward. Cold rations eaten standing up. Coffee, hot when it arrived. Lukewarm by the time anyone drank it. Men worked until they literally could not continue, then slept for a few hours and returned to work. Lieutenant Mott moved constantly among his men, checking progress, solving problems, encouraging exhausted engineers. He understood the strategic importance of what they were attempting. Every hour this bridge remained unfinished was another hour German forces had to organize counterattacks against the bridgehead. Every delay potentially cost American lives on the eastern shore, where infantry battalions were desperately defending against German counterattacks. The engineer companies committed everything they had to the task. Officers worked alongside enlisted men. Company commanders drove pins. Battalion staff officers operated boats. Cooks, clerks, and maintenance personnel joined construction crews when additional manpower was needed. The normal military distinctions between ranks and specialties dissolved in the urgency of the mission. Everyone capable of physical work contributed. By dawn on March 9th, the bridge reached within 50 feet of the eastern shore. The final sections required particularly careful work. The eastern approach had to be graded and prepared to accept traffic coming off the pontoon span. Bulldozers worked on the eastern bank under direct German small arms fire. German infantry positions in buildings and ruined fortifications overlooked the construction site. Snipers targeted equipment operators. Engineers working on final connections came under rifle and machine gun fire continuously. American infantry provided covering fire. Machine gun teams positioned in riverside buildings suppressed German positions. Mortar crews fired smoke rounds to obscure the construction site from enemy observation. The smoke helped, but could not completely prevent German fire. Engineers accepted the casualties and continued working. The mission was too important to stop. At 1300 hours on March 9th, 23 hours after construction began, the final treadway section was positioned and connected. The bridge now spanned the entire 512-foot width of the Rhine River, but completion meant only that vehicles could theoretically cross. The bridge still required final adjustments, additional anchoring, approach ramp construction, and safety railings. Engineers spent the next 2 hours completing these critical details. At 1500 hours, Lieutenant Colonel Fraser personally inspected the completed bridge. He walked its entire length, checking connections, testing deck surfaces, examining pontoon inflation and anchor cable tension. He approved the structure for traffic. The first vehicle to cross was a 2.5-ton cargo truck carrying critical ammunition to infantry units defending the eastern bridgehead. The truck rolled onto the pontoon deck. The bridge settled slightly under the weight exactly as designed. The truck proceeded across at 5 miles per hour. The pontoons rode low in the water, but remained functional. The truck reached the eastern shore safely. Within minutes, a steady stream of vehicles began crossing. Jeeps, trucks, half-tracks, tank destroyers, artillery pieces, towed by prime movers. The bridge handled each vehicle successfully. Traffic continued throughout the day and night. The crossing that seemed impossible 23 hours earlier was now functioning reality. The bridge's completion did not end the engineers' work. German forces recognized the strategic disaster the Remagen crossing represented. They mounted increasingly desperate attempts to destroy both bridges. Artillery fire intensified. German batteries fired over 1,500 rounds daily at the crossing sites. Shells impacted continuously. Engineers worked under this bombardment, repairing damage as quickly as German guns inflicted it. On March 10th, German forces deployed a new weapon against the bridges. The V-2 rocket, Germany's most advanced ballistic missile, was redirected from attacks on London and Antwerp to target Remagen. 11 V-2 rockets were fired at the bridge complex over the following days. The missiles arrived without warning, traveling faster than sound. Their explosions were devastating. None scored direct hits on either bridge, but near misses created enormous craters and inflicted casualties among engineering and infantry units in the bridgehead. The Luftwaffe committed its remaining operational aircraft to destroying the Remagen bridges. Between March 7th and 17th, German air forces flew over 360 sorties against the crossing sites. American anti-aircraft units defending the bridges fired thousands of rounds. They shot down dozens of German aircraft. The sky above Remagen became a killing zone for German pilots, but the attacks continued. Desperate missions flown by increasingly inexperienced pilots in obsolete aircraft reflected Germany's dire strategic situation. The damaged Ludendorff Railroad Bridge, weakened by the initial German demolition attempt and further stressed by continuous traffic and vibrations from nearby artillery impacts, finally collapsed on March 17th at 1500 hours. 28 American engineers were working on the structure when it failed. The bridge twisted, groaned, and dropped into the Rhine. Steel girders crashed into the water, concrete debris followed. Men fell with the wreckage. Some were killed instantly by falling steel. Others drowned, trapped beneath wreckage in the swift current. 18 engineers died. 63 were injured. The collapse shocked everyone who witnessed it. The bridge that had stood for 29 years, that had survived German demolition charges, that had carried thousands of vehicles and tens of thousands of soldiers across the Rhine, was gone. Twisted wreckage littered the riverbed. Rescue crews searched frantically for survivors. Divers went into the cold water repeatedly, pulling bodies from the debris. But the pontoon bridge, built by the 291st Engineer Combat Battalion, remained intact. It became the primary crossing point for all traffic into the Remagen bridgehead. Additional pontoon bridges were constructed upstream and downstream in subsequent days. By March 23rd, engineers had completed 7 separate bridges across the Rhine at Remagen. The bridgehead had expanded to encompass over 100 square miles of German territory on the Rhine's eastern bank. American forces poured across these bridges. The First Army established a massive presence east of the Rhine weeks before the planned northern crossings at Wesel. German forces, attempting to defend against multiple Allied advances, found themselves outflanked and surrounded. The Remagen bridgehead fundamentally altered the strategic situation in Western Germany. German commanders were forced to divert divisions desperately needed elsewhere to contain the American breakout. Those divisions were systematically destroyed in futile counterattacks against American positions. The engineers who built the first pontoon bridge at Remagen worked under conditions that defied standard military engineering doctrine. They constructed a 512-foot bridge in 23 hours while under continuous artillery fire, air attack, and commando raids. Standard peacetime construction estimates for similar bridges specified minimum times of 3 to 4 days. The Remagen engineers completed the work in less than 1 day. The cost was significant. Company A, 291st Engineer Combat Battalion, suffered 32 casualties during the bridge construction. 5 engineers were killed. 27 were wounded, seriously enough to require medical evacuation. Every man in the company was exposed to enemy fire continuously throughout the construction period. Some men were wounded, treated, and returned to work on the bridge within hours. The 51st Engineer Combat Battalion, which provided critical support and reinforcement, suffered similar casualty rates. Combined engineer casualties from all units supporting the Remagen crossing exceeded 300 men killed and wounded during the first 10 days of the operation. These casualties occurred not in dramatic infantry assaults or tank battles, but in the unglamorous work of building and maintaining bridges under fire. Lieutenant Hugh Mott survived the Remagen operation. He was awarded the Silver Star for his leadership during the bridge construction. The citation recognized his courage under fire and his technical competence in organizing and directing complex engineering work under extreme combat conditions. Mott remained with the 291st Engineers through the remainder of the European campaign. He participated in subsequent Rhine crossings, supported the advance through central Germany, and was present when American and Soviet forces met at the Elbe River in April 1945. After the war, Mott returned to Virginia. He worked as a civil engineer, designing bridges and infrastructure projects throughout the southeastern United States. He rarely spoke publicly about his wartime experiences. When asked about Remagen, he consistently deflected attention from his own actions to the enlisted engineers who performed the actual construction work. He maintained that any competent engineer could have directed the operation. What made the bridge possible was the extraordinary courage and determination of ordinary soldiers who kept working despite casualties and constant danger. The strategic impact of the Remagen crossing extended far beyond the immediate tactical situation. The unexpected Rhine crossing forced German military commanders to fundamentally reassess their defensive strategy. They had concentrated forces to defend against expected crossings in the north near the Ruhr industrial region. The Remagen bridgehead appeared in their rear, threatening to cut off German armies defending the northern Rhine sector. German High Command ordered immediate counterattacks to eliminate the bridgehead. These counterattacks consumed divisions and resources desperately needed elsewhere. The 11th Panzer Division, one of Germany's few remaining mechanized formations with significant combat power, was thrown against the Remagen perimeter. The division was destroyed in futile attacks against prepared American defensive positions, supported by overwhelming artillery and air power. Field Marshal Albert Kesselring, commanding German forces in the West, later wrote that the Remagen crossing was the decisive moment that made German defeat in the West inevitable. Once American forces established a secure bridgehead and constructed multiple bridges, German forces lacked the resources to both contain the bridgehead and defend against other Allied advances. The cascading effects of Remagen accelerated Germany's final collapse. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The engineers who built the Remagen bridges represented a particular type of soldier common in the American military, but relatively rare in other armies. They were technically trained specialists capable of complex construction tasks. They carried weapons and fought when necessary. But their primary contribution to victory came through engineering work, not combat. This combination of technical competence and combat capability characterized American engineering units throughout World War II. The United States Army recognized early in the war that modern military operations required extensive engineering support. Engineer combat battalions were organized, trained, and equipped to provide that support under all conditions, including active combat. The training was comprehensive. Engineers learned demolition techniques, mine warfare, bridge construction, road building, fortification, and numerous other technical skills. They also received standard infantry combat training, weapons qualification, and tactical instruction. This dual capability proved decisive repeatedly throughout the European and Pacific campaigns. American forces could advance rapidly because engineer units could quickly overcome natural and man-made obstacles. Rivers were bridged within hours. Destroyed roads were repaired or bypassed. Minefields were cleared. Fortifications were reduced. Each engineering success enabled continued offensive operations and maintained momentum that German and Japanese forces could not match. The contrast with German engineering capabilities was particularly stark by 1945. German pioneer units, roughly equivalent to American engineer battalions, were highly skilled and well-trained. German military engineering doctrine was sophisticated and effective. But by the war's final year, German engineering units suffered from the same resource shortages affecting all German military formations. Equipment was scarce. Replacement parts were unavailable. Fuel was rationed. Trained personnel could not be replaced after casualties. American engineer units faced no such limitations. They had abundant equipment, unlimited supplies, and continuous streams of trained replacements. When a bulldozer broke down, another was available immediately. When bridging equipment was damaged, replacement sections arrived within hours. When engineers became casualties, fresh graduates from engineer training schools in the United States filled the gaps. This material abundance, combined with technical competence and individual courage, made American engineering operations consistently successful, even under difficult combat conditions. The Remagen pontoon bridge remained in continuous operation until late March, when additional permanent bridges were completed. During its operational life, the bridge carried over 60,000 vehicles and hundreds of thousands of soldiers across the Rhine. The structure required constant maintenance. Engineers inspected it daily, repaired damage from artillery, fire and wear, adjusted anchoring as river conditions changed, and replaced sections damaged beyond repair. The bridge never closed. Traffic continued 24 hours daily, regardless of weather, enemy fire, or operational challenges. The 291st Engineer Combat Battalion received the Presidential Unit Citation for its actions at Remagen. The citation recognized the unit's extraordinary heroism and technical achievement in building and maintaining the bridge under extreme combat conditions. Individual decorations awarded to battalion members included 2 Distinguished Service Crosses, 37 Silver Stars, and over 100 Bronze Stars for valor. These decorations reflected both the danger engineers faced and the military importance of their accomplishments. The lesson of Remagen extends beyond the specific tactical and strategic circumstances of March 1945. The fundamental lesson concerns the decisive importance of engineering capabilities in modern warfare. Military operations require more than combat power. They require the ability to move forces rapidly, sustain those forces logistically, overcome obstacles, and build necessary infrastructure under all conditions, including active combat. Armies that possess superior engineering capabilities gain decisive advantages in operational tempo, logistical sustainability, and strategic flexibility. The American military understood this principle throughout World War II. Engineer units received priority in resource allocation, training, and equipment. They were employed aggressively at critical moments in campaigns. Their contributions, though less dramatic than infantry assaults or tank battles, proved equally essential to achieving victory. The engineers who built the Remagen Bridge demonstrated these principles with exceptional clarity. They proved that technical competence, physical courage, and determined effort could accomplish tasks that seemed impossible. They showed that ordinary soldiers, performing unglamorous but essential work under terrible conditions, contribute decisively to winning wars. They built a bridge that helped end World War II in Europe. They did it in 23 hours under continuous enemy fire. And they did it because the mission was necessary and they were the men assigned to accomplish it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.